Yeah, hello everyone, and welcome back. So today we are going to continue our J.P. Morgan Java backend developer interview question and answer. So last time we discussed almost 7 to 8 questions which was asked in JP Morgan interview. So today we will continue from there, and then we will see that what other questions was asked. So before starting the lectures, let's see that what questions we discuss in the first part. So questions was like, what are the key challenges in microservices? And the second question was, what is the API gateway and what is the role of API gateway? Third question was like, what is data consistency and how do you handle data consistency in a distributed microservice architecture? And the fourth question we discussed that what happens if a microservice fail and how to prevent it. And also we discuss the questions like, how could you design an API gateway that handles authentication, rate limiting, logging, and the request transformation. And also we discuss about the difference between the monolithic and the microservices. And also we discuss how do you test a microservice that depend on many other services. So these are the some questions which was asked, and we have discussed these questions in a very depth manner in our last lecture. So guys, if you have not watched my previous video on this series, then please go and watch the lecture of my previous video, because that will help you to understand all these seven questions. And today we are going to continue from here. So the next question which was asked was how do you design a rate limiter for an API? So this is a very important questions. If you are getting any interview for a microservices, then these questions may be asked. So here basically you need to explain about what is rate limiter, and then you have to go with the answer. So first you can say that designing a rate limiter for an API is a critical to prevent abuse, to prevent ensure that there is a fair usage, and also to protect backend resources. Okay, so some of the steps are first steps, you need to understand the requirement. Okay, so first you need to understand the requirement. So first you need to know that a rate limiter criteria, that how much request per minute or per second you have to add in the scope of your designing. For example, per user, how much request is allowed, per IP, per API key, per endpoint. Okay, and also you need to understand the burst allowance. It means, can a client exceed the rate limit briefly? And then you should also understand what are the penalties behavior. Should we block, delay, or throttle request? So these are the some questions which you can ask from the interviewer, that because you need to understand the requirement first, right? So you cannot simply answer this, but you need to understand, and then according to the requirement you can frame your answer. Okay, so the second step is choose a rate limiting algorithm, because there are n number of algorithms are there by which you can implement a rate limit. Okay, so first algorithm is their fixed window, in which we count the request in a fixed interval of time. Let's say that how much request is passed per minute. And then there is some algorithm which is sliding window, where more accurate than fixed uses multiple time buckets. So this sliding windows is a more good approach than a fixed window. Okay, and then there is third algorithm like token bucket. So token bucket is like tokens are added at a fixed rate and request consume tokens, so it allows burst also. Okay, and there is another algorithm like leaky bucket, so like a token bucket but enforce a constant output rate. So in real time rate limiting with a burst support, token bucket is often preferred. So token bucket is the most preferable algorithm in a real time rate limiter application. So but you need to understand these scenarios, then only you can decide that which algorithm you have to pick. So basically you can means tell the interviewer that these are the some algorithms which we can pick up, and also you can explain this algorithm in a one liner, so that he will understand that you have a better understanding about this things. And in the third step you need to decide whether that what you need to implement. So you need to implement the rate limiting in the client side, or in API gateway, or in backend application, or as a distributed system. So client side is not much secure, where it can be bypassed, where you implement rate limiter in the client side. Okay, and in the API gateway, which is most recommended if you're using a centralized enforcement. And the third is like backend application, so it is good for custom logic. Basically we can be used with Java, Node, Python, like languages. And one is distributed system, where you can use Redis or similar type of like technology, where you share the state across instances. So these are some like implementation algorithm which you have to decide. Okay, and the step 4 is to store the rate limit state. So you need to understand that where you are going to store the rate limit state. For example, you need a fast inline memory, like you can use Redis or any in memory storage, DB, or anything, right? So in Redis it is ideal for distributed system, and in memory for single instance app only. Okay, and then fifth is like implement the logic. So these are some like prerequisite, where you need to understand that according to the scenarios, this prerequisite requirement will change, and which algorithm will be more suitable for your request, right? And also now there is a Redis, yeah. So the fifth step is like implement the logic. So this is how you implement the logic. Basically you create a rate limiter class, and then you create a capacity and the refill rate per second, and also you create a map with the user bucket. Okay, and this is bucket as a class, where the properties are token and the last refill time. Okay, so this is the bucket class. And then there is a allow request method is there, which is returning an boolean. So you need to pass that per user ID how much request is allowed. So this implementation you have to add it here. Okay, and then also like refill, where you need to pass the bucket and then you need to add the logic. Okay, yeah. So by this way you need to add some implementation logic for the rate limiter. So this can be done once you decide that how much capacity is there and how much refill rate per second you have to use. So these questions you can ask earlier, and then you can go with the implementation, right? So the sixth step is like respond appropriately, means when a rate limit is hit, then what respond you have to provide. So this is also important, that let's say if rate limit is passed, then response like 4 to 9, which is says too many requests. Or you can say, or like you can do retry after 30, yeah, so you can do a retry after 60 milliseconds, something like that, which includes the rate limit header, like where you need to pass this like x limit 100, x rate limit remaining, x rate limit reset, and all. And also at last you have to monitor and tune. So you have to log the rate limiting matrix, like how much per second it hit, and how much rate is remaining. Okay, and you need to use alert for abuse patterns, and also you need to adjust the limit based on the usage and the server capacity. So step 8 is like yeah, so step 8 is like kind of enhancement, where you can use a dynamic limit. So it is not like as per the requirement, it's not fixed that per minute this much request can be done. So it can be dynamic also. Okay, and blacklist and whitelist certain IPs or keys. Let's say you have to blacklist certain IPs, you have to whitelist certain IPs, which means it means that certain IP will be blocked or it is allowed to access. Also you can use a token bucket implementation using Redis script for like atomicity in a distributed system. So these are some like steps which you can take, and these are optional, means it depends again as per your requirement, that what you can use. But as per the library, if you're going with a Java, then go with a bucket 4G or resilience 4J. If you're using node.js, then go with express rate limit. And for Redis you can use INCR and TTL for fixed window rate limiting. So these are some steps where you can use for implementing the rate limiter in an API. So like this, you have to explain that you need that. Yeah. So then the interval will know that that you have the knowledge about these things, right? Okay. So next, question was like, how could you make a service highly available and scalable? So this is again very important questions where the interviewer wants to know about that whether you have a knowledge about the services to make a more scalable and highly available. So in the distributed system, these steps are very important, right? So high availability means a system is highly available. It is continuously operation, and operation time can be approx 99.99 percentage. Okay, even when some component fails, then also means it says that your component is highly available. So goal is to minimize the downtime and measure uptime in a SLA form. So that is 99.99% should be the availability of your system. And the second is like scalability. A system is scalable if it can handle increased load by adding more resources without degrading the performance. So when you say your system is scalable, when it can handle means increased load, and where it is not degrading the performance, so then only it is says your system is scalable. It means with the scalability, if the load increase, it can handle and without degrading the performance. So there are basically two type of scaling. First is vertical scaling, second is horizontal scaling. In vertical scaling, it increase the resources on a single node, and horizontal, it adds more nodes. Okay, so there are some system design strategies to get the high availability or a high scalability for any particular system. Okay, so first is like load balancing. So this is very important, that load balancing, because see, so basically, a load balancing in a distributed traffic across a multiple servers, example where we have a hardware, software, and the cloud is there. So load balance should support health check, and also it should support like sticky sessions. So sessions should not get expired. It should support, also it should support auto scaling integrations. Okay, so second is like stateless service architecture. So basically what it does, it keeps your application stateless to enable horizontal scaling. Because so state is stateless, it means every request you need to send the information, so which will help to scale your system horizontally. Okay, and the session start should go with something like redis, or for session or database per or for like database for persistence. Okay, so something like that. So third is like redundancy. So redundancy means deploy multiple like replicas of your service across the zones. Okay, so you can deploy your resources into the multiple zones, which will help us to, yeah, so which uses like active or active passive setups. Okay, so it eliminates basically the single point of failure. The next is design you can opt for is auto scaling. So this is also very important, because auto scaling adds or remove the instance based on the load monitored. Because you have seen that sometimes when with the means where yeah, so in the application we have seen that when the festival comes, the application load get increased, right? So where you need to scale up some of the components, right? So your component should be have a feature to get auto scale, so that it can handle like more loads without failing. And also you can monitor by like CPU uses, request latency, and the queue length, right? So basically there are n number of tools by which you can do the auto scaling. The first, you can use like AWS auto scaling groups, or again we have something like Kubernetes like horizontal pool auto scaling. Okay, so these are some tools which you can use for availing the auto scaling. The fifth is like database scaling and the availability. Again, database scaling is very important, because in the replication, where the read replicas for horizontal read scaling and the master slaves or multi-master for write availabilities. So these are some important things. And again, like in the database, there is a database like sharding is there, where we split the data into the different sections, right? And also like failover, so you have to manage the failover, and also like automatic failover backup, or you can also see the backup restores and the multi-agent deployments, right? The next is like caching. So caching is also important because it's basically offload the frequent or expensive operations. So sometimes like when we do the same operation again and again, so it should not hit the API, or it should not go to the database, because it will increase the performance. So better you can use the caching mechanism, where if the similar kind of operation is happening, then those operations will fetch the data from the cache. It will not actually hit the database directly. Yeah, so this will be helpful for both scalability and the response time. And again, the next design you can think of is a asynchronous processing. So this, yeah, so this is also very important, where the messaging queues, Kafka, and the Redis MQ and the SQS like come into the picture, right? Where which help in loading, smoothing, and producing, consuming. All this can be take care by this like Kafka or the messaging queue for asynchronous processing. Next is like monitoring, logging, and alerting. Okay, so this is very important again, because we have a different tools to do the monitoring, for logging, and for alerting, right? So we have like Prometheus, Grafana, and the other tools are there, which helps in like visibility, and also it helps in like failure detection. Also you can track the response time and all. So yeah, these are the some system design strategies which you have to think of before making your component design very high available and scalable, right? So yeah, so the summary I can tell, that to make a system highly available and scalable, first you have to focus on eliminating a single point of failure. Okay, so and also using a stateless service with auto scaling. Also the third point is like you can use the queuing and the async processing. Also you can use caching, so that it will reduce the load. Also you can do the monitoring and logging and alerting, which will more focus on regarding the request, and also it can detect the failure. Okay, and also you can deploy across the different zones, so that it can help us to escape from the disaster recovery, right? So these are the some points which you should take care while implementing like high available and scalable system. Okay, so the next question he got was simply like write a Java code to check if the parentheses are balanced in an expression. So I have seen that this is a very important question, which we have seen in the many interviews from the different organizations. They ask that you have to write a Java code and check if the all the parentheses are balanced in an expression. Okay, yeah, so this is a sample code I have added, but let me move you to the Visual Studio, where I have already added this code. Okay, we will try to understand the code, and also you can try with your own means by yourself, and you can try to implement this. Yeah, so in this, basically what you can do, we can create one is balance method, where you can write yeah, the balance method basically to check. So here you can see my input. We have a main method, and we have the three expressions. First is this, second is this, third is this, and then we have to check that whether we have like opening and the closing parentheses are matching or not. And in the first system.out, we are checking whether, and then it is returning true, false, true, something like that. So first, so is balance is checking, and here we are passing the expression as a string, and then here we are using a stack basically. So see, so what approach we are going to take? first we are going to take a stack, and then we are going to push each opening like bracket to the stack. Okay, and then on the closing bracket we are going to pop, and then we are going to compare whether the closing and the opening bracket is matched or like mismatched. If like mismatched or stack is empty, then we are going to return false. Okay, and at the end, if the stack is not empty, then we are going to return false. Okay, because some bracket may also be left open. Yeah, so this is the funda we are going to use in this check. So is balance, and then we have created a stack, and then we are looping with this string expression with the each character. And then we are, if this character is either bracket or square bracket or like curly bracket, then we are just pushing this to a stack. And then further, for closing bracket, we are checking if it is matching with the closing bracket, then we are popping that stack. If it is not empty, then we are returning as a false. Okay, and then we are returning is empty. If stack is empty, then it means expression is balanced. And then we have a is matching method is going to call here, which checks. Okay, if this or this or this, then it is return true or false, right? Yeah, so like this it will check, and then it will return true or false in the is matching. Okay, yeah, so like, yeah, so like I hope you can understand this logic. Yeah, so this is a very important question I have seen, and if we run this, then you can see in the first output is true because expressions is fully open and closed. But here it is not done because square bracket, yeah. So here this expression is not correctly open and close in a proper manner. That's why this is false. And again, this is true. Okay, because it is correctly open and correctly closed in a balanced manner. So expression third is giving true. Yeah, so this is the one of the question he has been asked in the interview. And the another question was like find the longest substring without repeating characters. So he has been given one string, for example abc abc bb. So here we need to find the longest substring without repeating characters. Okay, so here the answer is like ABC, right? Because otherwise everything is getting repeated, right? So with the length of 3. So we need to find the longest. Yeah. So like you can try this question with your own. So here I'm not going to provide you the like code for this. But yeah, so like this is the question which was asked in that interview. Okay, so you can try by yourself. So if you required the output or the code for this, then you can comment it out, then I will try to provide the video in this. Okay, so the next question was what is the difference between synchronize and like rentrant lock and the volatile. So this is again important question, right? So yeah, so like in java like synchronize, rentrant lock, and the volatiles are all mechanism used to handle the thread safety and concurrency, and they serves a different purpose and also have a different capabilities. Okay, so first we'll discuss about the synchronize. So purpose of the synchronize is to ensure the mutual exclusions. Okay, it means that only one thread at a time can execute a synchronized block or method for a given object or class. It means if there is an n number of thread, then it is not allowed to execute a particular method or a section of code by a multiple thread at a single point of time. It means a particular thread can only operate on that method or particular section of code. So that is what a synchronize makes sure, that a particular method or a particular block can be accessed by only one thread at a time. Okay, so the characteristics are like automatically acquires and release a monetary lock. Basically how it happens, actually it locks that portion, it locks a object. Okay, and in that locking object only one thread is allowed and the lock is done. So if like another thread tries to access that method in that object or in that class, then it will be not allowed because there is already a lock in the object. Okay. And also it can be used on method or code block. It is simpler and lesser error prone, cannot interrupt a thread waiting for the lock, so no way to try locking without waiting. So these are the some like characteristics of a synchronize keyword. So in the sample code you can see we are using a counter class where you have a count like property as a 0, and we have an increment method and a get count method. So the main point is that in the increment method we are using a synchronize, okay, keyword. It means we are making this increment method as a synchronize. It means at a time only one thread will be allowed to increment this count. Okay, once all the count will get increased, then only the lock will be released. So in this way you will not see, so there will be yeah, so you will get the result which you are expecting. Okay, in a multi-threaded environment. And here in the get count also you will get a lock, and then at a time only one thread can operate. So this is about the synchronize. So even yeah, so output will not vary because even if multiple thread call increment method at the same time, then synchronize will ensure automaticity. Okay, then it will only allow one thread to execute this increment method, right? So yeah, so next is like redundant lock. So in this, basically the purpose is to provide a mutual exclusions like synchronized but offer more control. So this like redundant lock is more control, have a more control than synchronized keyword. Okay, and the characteristics is like explicitly it acquires a lock and release the lock. So you can explicitly acquire a lock for a certain method or certain portion of a code, and then also you can explicitly release it. Okay, so it can be try to acquire a lock with a try lock method and also with a timeout. So here is a try lock method which can be used to acquire a lock. Okay, and it can be interrupted while waiting for a lock, and it support fairness policy, first come first serve, because whichever thread will come first, then like that thread will get lock and it will be served, right? Yeah. So next, it can must be manually released. So once the lock is done, then it have to be released manually. Okay, it will not release automatically. It means you have to use unlock. You have to unlock that particular object or class. Then only it will be helpful. Okay, so as a sample code, I have added that there is a counter class where we are creating an object of this rent lock class, and then in the increment method we are again creating the lock. So we are acquiring a lock method, and in the try block we are trying to increment the count, and in the finally block we are unlocking it. So you have to ensure that the lock should be released, and in the get count you will get the count of this. So this is rent and lock, and you have the more control because in this you are explicitly putting a lock, and then explicitly you are unlocking a lock. Okay, yeah, so this is why this is important. So next is like volatile. So volatile keyword is used in Java for ensuring the visibility of changes to the variable across a thread. So it like does not provide like atomicity or like mutual explanations, but it will help a thread to read the value from the main memory. Okay, and not from the CPU cache. So basically every time the thread will get a very updated or the real value because it reads the value from the main memory. So best of the so it can be used as a flag or a state checks, and it cannot be used to make compound actions increment or a variable atomicity, right? So for example, here I have written a sample code where like share resource is a class, and this running boolean is a volatile. So this running so if a thread comes and tries to read this running variable, then this running variable will get the value from the main memory. So it will not get the value from the CPU cache or anything else. So always it will get a real time value, I mean the actual value, updated value. Okay. Yeah, so in this manner you can implement a volatile. The next was like when to use what. Okay, this is also important. If you are using synchronize, then you can use for simple mutual exclusions when you don't need an advanced feature. And for entrant lock, if you need a customized lock, then where you have to use try lock, and also like interpretability and the fairness is required, then go with the redundant lock. And volatile, like when you need to make sure that variable latest value is visible, okay, then always go with the volatile keyword. Okay. Yeah, so like these are the some questions which was asked with him, with one of my friend in like JP Morgan interview questions, and he has like passed through it. Now he has already attempted the second round. So guys, if you want the interview questions for the second round also, then you can like put this on the comment, then I will try to take the questions from him, and then I will try to explain the answers of this, and also I will share all the questions which was asked to him in the interview. Yeah, so guys, I hope you got some insight that what questions can be asked, and you can also try with like similar kind of questions for your interview. Yeah, so like I hope these questions are helpful for you. Yeah, so like you can subscribe the channel, and you can hit the bell button, and yeah, and like wait for the next interview questions session. Thank you.